Today's lesson is going to focus on quadratic equations, their functions, zeros, and modeling. Part 1. It's quite a lengthy lesson, so we're splitting it up into 2 days. Let's take a look at the two functions. We have the function f of x is equal to negative 5x plus 4, and f of x is equal to negative x squared minus x plus 2. We know how to solve the ones on the left quite easily because these are linear functions. And we know linear functions are nice straight lines. And I know that it's a falling linear line because it has the negative x. I also know it's linear because I have a power of 1. The one on the right-hand side are negative x squared minus x plus 2. This is a quadratic. And we've talked about these quite frequently. And this is going to be a frowny face. I know this because of this negative. We'll talk more about that later. But I also know it's a quadratic because my x is squared. When I have a quadratic, I have one of 3 options for solutions. I can have 2 real solutions where I can see along the x-axis where my graph is crossing the x-axis. I could have 2 complex solutions where I might have a graph such that it has solutions, but I don't actually see them cross the x-axis. Or I could have one solution where just the tip of my graph crosses one time, and we're going to call those double solutions. We're going to talk about that a little bit later. Just by having this f of x out front says that it's a quadratic function. And a quadratic equation then is when I have no function, but I just set it equal to 0. And we talked about this a little earlier, that when I have zeros, x-intercepts, or solutions, we're just trying to find the location where they cross the x-axis. And these are all synonyms for the same thing. Another word you might come across is the word roots. Roots are all the same thing. They all mean the same thing. The zero product principle states that if I have 2 items that are being multiplied together to get 0, then either one of these must equal 0 for it to be that way, because we know anything times 0 is 0. Also, if I take the square root of a value, we know that we're going to end up with a positive and a negative value when we do that. So when I take the square root to solve for x, I need a positive and a negative value for it. And we'll talk more about that on the next slide. There are different ways in which we can solve quadratic equations. We're going to talk today about graphing. Factoring is something you should already know how to do, and then completing the square. If you were in Algebra 2, you've already gone over these. If you've done an Algebra Prep 3 with myself, we've already gone over these ways. But sometimes there's better ways than others to solve based on what we have. Graphing is okay, but we don't always get the exact solution. We get more of an approximation. So if approximation is okay, then we can use graphing. Factoring doesn't always work because we know that sometimes they're just simply can't be factored. So if it can't be factored, it's not always going to work, and therefore we can't always find the solutions. Completing the square will always work. It gets kind of messy, so it's not always the nicest way. On the next lesson, we'll talk about the quadratic formula and different principles with that. So let's use a graphing calculator to find the zeros of the functions and round to 3 decimal places. So for a and b here, I plugged them into decimals and I found the 2 locations with which it crossed the x-axis. So when I graphed 3x squared plus 2x minus 4, I found that our graph crossed the x-axis in 2 locations. So our solutions to this first problem are x is approximately negative 1.535 and 0.869. When I graphed my second one, I also see I have 2 solutions. I see where it crosses the x-axis. So x, we say, is approximately negative 0.347 and 1.8181. All right, now let's get into solving by factoring. When we solve by factoring, we want to make sure our equation is set equal to 0. So when I look at 2x squared minus x equals 3, I see it's not equal to 0, so I'll subtract 3 from both sides so that I end up with 2x squared minus x minus 3. I see that there's a number in front of x squared, so I need to find two numbers that multiply to -6, but yet add to -1, the middle number. -3 times 2 works, so I split my middle term into 2x squared minus 3x plus 2x minus 3. And I regroup. I see that my first set share x in common and my second one shares just plain old 1. Now this is my way of factoring. If you have a different way, that's okay too. I see that they share 2x minus 3 as their common binomial, and the leftovers are x plus 1. Now that I have it set equal to 0 and I have it factored, I set each factored piece equal to 0. So 2x minus 3 is 0 and x plus 1 is equal to 0, and then solve each one respectively. So x equals 3 halves, and when I subtract 1, x is also equal to -1. So my solutions are -1 and 3 halves. On the right here, I have our graph. I see that the solutions I found via factoring match my graph. So using Desmos to help us graph to see that we solved correctly is going to be helpful for us in your homework. And note that 1½ is the same as 3 halves because 2 goes into 3 one time with 1 left over. Let's solve 2x squared minus 10 is equal to 0. Notice here that I don't have an x value, I just have an x squared. So solving by taking the square root might be our easiest way to do this. So I'm going to start solving to get x by itself. So we first need to add 10 to both sides. After I add 10, I can divide by 2, giving me x squared is equal to 5. Taking the square root of both sides, I get x is equal to plus or minus the square root of 5. Notice on that first slide I said that when we take the square root we need to have a positive value and a negative value. So when we do that we have two solutions. We have the positive square root of 5 and we have the negative square root of 5. So although it looks like we just have one solution, it really is two, one with the positive and one with the negative. We can check our solution by plugging it back in to make sure that we solved correctly. So when I take the square root of 5, I know that the square root and the square cancel, so I just have 2 times 5, which is 10, and 10 minus 10 is 0, so this is true. So again, the solutions are positive square root 5 and negative square root 5, or written more simply, plus or minus the square root of 5. When I graphed, if you were to take the square root of 5, we would see that we get positive or negative 2.236. In your homework, I will ask you to be specific and show me how to solve using a specific way. So although graphing is helpful, we can't just state the graphed solutions. You need to show me you know how to do these steps. Let's find the zeros by completing the square. So here I'm asking us to complete the square. So when I'm completing the square, I need to have my equation. We know it's ax squared plus bx. We're going to set it equal to c, where our a value has to equal 1. And I'm going to show you what happens if it doesn't equal 1, what we have to do. So right now when I look at my x squared minus 6x minus 10, I see that I don't just have my x values on the left and the number on the right. So I need to add 10 to both sides in order to get my value to the right, giving me x squared minus 6x equal to 10. Now we're going to take our -6 value. I want half of -6, which is -3. Then I want to square that number. So I want to take half of it and then square it. We're going to create a perfect square trinomial by doing this. And I'm going to underline that -3 because we're going to use that every single time in order to help us. So -3 squared we know is +9. So what I want to do then is add this +9 to both sides. So we have to keep it equivalent. So add what we do to one side, we have to do to the other. Now I'm going to factor. And we're going to factor because now I just created a perfect square trinomial. I'm always going to use the number right before I square. This will give me x minus 3 squared. And if I were to rewrite that, x minus 3 times x minus 3 and redistribute, I would end up back at x squared minus 6x plus 9. Then I have 10 plus 9, which is 19. Okay, so to get rid of the square, we're going to take the square root. This gives me x minus 3 is equal to plus or minus the square root of 19. X isn't quite by itself yet, so I need to add 3 to both sides. When I add 3 to both sides, I end up with 3 plus or minus the square root of 19. Notice I am not taking 19 plus 3 to get 22. Notice that is not what I'm doing. I cannot add 3 and the square root of 19 together because they are not the same. They are not like terms. So what I have then is two solutions. I have one with the positive value and one with the negative value. So when I plug this equation into Desmos, I see that it matches if we were to actually plug that into our calculator. So our exact answers are 3 plus the square root of 19 and 3 minus the square root of 19, or approximately 7.359 and negative 1.359. Let's solve by completing the square. Here I see I have x squared plus 8x minus b is equal to negative 15. So I have my x's on the right, my number on the, my x is on the left, my number on the right. I need to make sure that the number in front of x squared is 1, which it is, so there's no number in front of x squared. So first of all, I want to take half of 8, which is 4, and then I want to take 4 and I want to square it, which is 16. I'm going to keep this 4 because we're going to need that later once we factor. It's always going to work out for us when we factor. I need to add 16 to both sides to keep it equivalent because we're creating a perfect square trinomial. I now have x squared plus 8x plus 16 equal to negative 15 plus 16. So I'm adding that 16 to both sides. Okay. Now I can factor the left-hand side. We've created a perfect square trinomial, hence completing the square. And I'm going to use that highlighted 4 when I factor. So I'll have x, notice it's a positive 4, so x plus 4 squared is equal to 1, because negative 15 plus 16 is 1. To undo the square, I'm going to take the square root of both sides. This then gives me x plus 4 is equal to, we need the positive and the negative version of the square root of 1. And the square root of 1 is 1, so plus or minus 1. Now I need to subtract 4 to get x by itself. So I have two answers here. I have x is equal to positive 1 minus 4 and negative 1 minus 4. So x is equal to negative 3, since 1 minus 4 is negative 3, and x is equal to negative 5. And lo and behold, when I graphed in Desmos, I see that they match negative 5 and negative 3. Let's try one where the number in front of x squared isn't as nice. But we first have to make sure we have it set up appropriately. So when I look at this, I do not see all of my x values on the left and the number on the right. So I first need to get my x values on the left. So what I'll do is I'll subtract 3x from both sides, giving me 2x squared minus 3x minus 1 is 0. And then I'm going to add 1 to both sides so that my 1 is on the right-hand side. My x's are on the left, my number's on the right. Now if I notice there's the x squared there, there's a number in front of x squared. We cannot have that. So I need to divide everything by 2 so that there's nothing in front of x squared. This gives me x squared minus 3 halves x is equal to 1/2. Okay. So now I'm going to take my negative 3 halves. Notice there's a negative there. I want half of negative 3 halves. To multiply fractions, we go straight across, so negative 3/4. Now I want to take negative 3/4 and square it. So right before I square it, I'm going to highlight this. We're going to use that when we complete this square to make it easy for us. And negative 3/4 times itself gives me positive 9/16. I need to add that to both sides of my equation to keep it equivalent. So 9/16 and 9/16. On the left, we can factor so easily because I already have part of my factored form here, so there's nothing to think about. So x minus 3/4, notice we see a negative, so that negative follows us. And if I want to add half plus 9/16, I need a common denominator. So when I look at half and I look at 16, I'm going to need to multiply them by 8. So this would give me 8/16. So 8/16 plus 9/16 certainly gives me 17/16, which is listed here. Okay, now I want to take the square root of both sides. This then gives me x minus 3/4 is equal to the positive and negative value of the square root of 17 over 16. But I know, using my radical rules, I can split them apart because lo and behold, the square root of 16 gives me 4. Okay. I still need to get x by itself, so I want to add 3/4 to both sides. That gives me 3/4 plus or minus the square root of 17 over 4, but notice they have a common denominator here, so we can write it as one big fraction, which is how you're typically going to see them, especially when we work in the lesson tomorrow. Notice I have two solutions. I've got 3 plus the square root of 17 over 4 and 3 minus the square root of 17 over 4 for a total solution of 3 plus or minus the square root of 17 over 4. And if we were to take our graphing calculator, graph this, and take our scientific calculator and add them and subtract and then divide by 4, we would end up with these two approximations here. Let's try one more. We've got 3x squared minus 6x plus 2 is equal to 0. So first of all, I need to set this equal to the x's on the left and the number on the right. So I'm going to subtract 2 from both sides. That now gives us 3x squared minus 6x equal to negative 2. Notice the number in front of x squared is not equal to 1, so I need to divide everything by 3. This gives me x squared minus 2x equal to negative 2/3. Right? So now I take my number in the middle here. I want half of negative 2, which is negative 1. And then I want to take negative 1 and square it. I'm going to highlight this because this is going to be helpful when I factor. And negative 1 times negative 1 is positive 1. Note that positive 1 is the same as 3/3, right? We want to add that to both sides, giving me x squared minus 2x plus 1 equals negative 2/3. And instead of writing plus 1, I'm going to put plus 3/3 because I know I'm going to have to add them together anyways, so why not start off with the common denominator and help myself out. On the left, we can factor using our highlighted number. This will give us x minus 1 squared equal to negative 2/3 plus 3/3 is 1/3. Okay. So now I want to take the square root of both sides. So I now have x minus 1 equals to plus or minus the square root of 1/3. I know that this is the same as plus or minus the square root of 1 over the square root of 3. I know the square root of 1 is 1, so this is plus or minus 1 over the square root of 3. We don't like to have a radical in our denominator, and we've talked about that in Algebra Prep 3. So I'm going to multiply this by the square root of 3, because I know the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 we know is 3. So this altogether would be then plus or minus the square root of 3 over 3. But x still isn't by itself. We still have x minus 1. So I'm going to take this and say I'm going to add 1 to both sides. So x is equal to 1 plus or minus the square root of 3 over 3. Creating a common denominator, this is the same as 3/3 plus or minus the square root of 3 over 3. And combining it into one fraction gives me 3 plus or minus the square root of 3 all over 3. Again, if I were to take my calculator, add and then divide, or subtract and then divide, I would see my approximations are here and here. Two trains are leaving a station at the same point. So let's assume they're leaving the station here. One train is traveling due west and the other is going south. So one is heading west and one is heading south. The train traveling west is going 20 kilometers per hour faster than the one heading south. So whatever speed that the one heading south is, which we're not quite sure, so we'll label their rate as just plain old r. The one heading west is r plus 20, so 20 kilometers faster than. So 20 plus however faster the other one is going. We know that the time they've been traveling is 2 hours because we know from our last unit that distance is rate times time. So we're multiplying each one of the rates by 2 because they're traveling for 2 hours. It says that from their endpoint to endpoint, they are 200 kilometers apart. Find the speed of each train. So we're going to use Pythagorean's theorem. Again, that's a squared plus b squared is c squared, where a and b are the legs. So I'm going to take 2 times r plus 20 squared, which is our a. So this is our a squared. Here is our b, which is r times 2, or 2r squared, equal to our c value, which is 200 squared. On the left, we'll have 2 squared, which is 4, times r plus 20 squared. 2r times 2r is 4r squared, and 200 squared is 40,000. Notice that they're all divisible by 4, so I'm going to divide them all by 4 here. When I do that, I see I'm left with r plus 20 squared plus r squared equals 10,000. So it's getting a little bit easier for us. Well, on the left-hand side, though, I'm going to take r plus 20 times itself. So r plus 20 times r plus 20. That gives us r squared when we're distributing plus 20r plus 20r plus 400. I can combine like terms so that I get r squared plus 40r plus 400 plus our r squared here and our 10,000. I'm going to combine like terms and subtract all at the same time, because if I'm going to do anything, I'm going to have it be set equal to 0. So I'm going to subtract 10,000. I notice I have r squared and an r squared for 2r squareds plus 40r minus 9,600 equal to 0. Again, they're all divisible by 2, so I'm going to simplify again, which is nice, leaving us with r squared plus 20r minus 4,800. So I'm going to factor. This looks like something that's factorable. So I want to find two numbers that multiply to negative 4,800 and add to 20, which looks like it's going to end up being 80 times negative 60, since 8 and 6 is 48. and 80 minus 60 is 20. There's no number in front of r squared, so I can jump to my factored form of r plus 80 and r minus 60. I know that when we have it in its factored form, each piece is set equal to 0, so r plus 80 is 0 and r minus 60 is 0. When I solve and subtract 80 and add 60, I end up with r is negative 80 and r is 60. Well, we know that a negative value doesn't make sense in the context of the problem, so we can completely ignore this negative 80 because we can't go negative 80 kilometers per hour. So let's check to make sure 60 works. So when I plug 60 in for my rate, is 60 plus 20, which is 80, times 2, 160, good. And 60 times 2, when I plug it in here, is 120. When I plug it back into a squared plus b squared, does that equal 40,000? And it sure does. So the train that's heading south, its rate was just plain old 120 kilometers per hour. And the one that was heading west is traveling 160 kilometers per hour. And now you can complete our homework for lesson 3.2 part 1.